So this is Bedrock Tech Talks. We are a user group with nearly 1,000 people. We're distributed all over the globe. We have a Chester contingent, that's where I am. So we have in-person meetings every month, but we also have a virtual virtual meetup on the 4th Thursday of every month. So have a look at the other events we've got on. Because we are aligned with Azure, with Microsoft for the user group, we are able to provide a discount to SQL Bits. So that's on screen. It's 19th to 23rd of March, not that far away. Granted, it is a long way for some people. But if you can make it, it's actually a really good event. I've been 4 times, I think, and there's always stuff to learn. You meet loads of people and you have loads of fun. So when you book, if you do come, you can use the code UG5Bedrock, and that'll give you 5% off. But as a reminder, the Saturdays are always 100% free. So if you're unable to get time out of work, or to get work to pay for it for you, come along on Saturday. There's 60, 70 talks on the Saturday. Something for everybody, all sorts of topics. It's a really good event, so I thoroughly recommend it. That is it. So I'm going to stop sharing. Jeff, could I ask you to go first, and I'll try and get Lee joined in.
Yeah, let me try doing this sharing thing again. Can you see the PowerPoint now?
Yeah, I do.
Okay, so let's get started. This is the Bedrock Roundtable. It's the 18th of January, and we're going to talk a little bit about recursive CTEs. And this is supposed to be a lightning round, but I went a little bit extra here. So we're going to talk about a practical example of when not to use recursive CTEs. This is actually a code smell when I see recursive CTEs, especially if they're non-hierarchical. My name is Jeff Moden, and just a little bit about me. I am the fellow that coined the term rebar, and I realize there's no E in there, but I pronounce it rebar because it reminds me of the metal rods hopelessly stuck in cement forever and not going anywhere fast, just like rebar code, which stands for row by agonizing row. And somebody actually made a wiki entry on that, saying that I had invented the term, and I didn't do that. It wasn't me, somebody else did. I also helped make the tally table. You might know it as a numbers table, a household name, and you can read the rest on about this. The big thing is SQL Server is not only my profession, but it's also my hobby. And yeah, I know I need to get a life, but I've got a face for radio. So let's get along with this here. Like I said, this is a lightning round. So if you could, please hold all the questions until the end, unless you just have this overwhelming, I've got to do it now. But yeah, I don't think you'd be disappointed. So what we're going to do is we're going to use a classic problem of expanding date ranges as an example. And the method that we're going to use is also known as relational multiplication. We take a little bit of data and we're going to turn it into many rows, not totally as a cross join, but as a bit of a controlled cross join. So if you look here, we have a typical row in a table. It's got a task ID, a start date, and end date. And what they want to do is create all the dates from the start date through the end date. In other words, both dates are inclusive, so that it looks like this, where we have a task ID in the original table, and it's reflected in every row in the result. We have a start date, and we have an end date, and we have all the dates in between. And it's not uncommon to have something this small, but then somebody will say, yeah, well, I have multiple rows and I want to do this for each task ID. And so once again, there's the task, there's the start date, there's the end date, and all the rows in between. And then they say, okay, yeah, that's great. We want to do it for 10,000 rows, and we're going to have up to 90 days for each range. And that's when people lose their minds and they start thinking about how to do that. And the first thing that comes to mind is typically while loops. And then they go, oh, I can do things in a set-based manner. And what they are calling a set-based manner is recursive CTEs. And I'm here to tell you it's not set-based. So let's do a quick little demo. Great, here we go. And I apologize for a little fumbling on the keyboard, but Microsoft absolutely put the screws to me with changing teams. So this is my desktop, and what I'm going to do is, and I can send this to James so that he can go through it. But this creates a table of 10,000 rows. And what it looks like is this. You can see each task has a start date and an end date. And on all of these right now, just for this demo, just to try to keep it short, I've checked all of these. Actually, I created all of these to make sure that the from date is always less than the to date. And I've pre-counted the number of days in the range just for troubleshooting. You can see this one. Let's see, here's one for 1 day. And so the from date and the to date are the same, just to give you an inclination as to how the dates work here. Alrighty, and if we sum all of those day ranges up, you can see it's going to make a little less than 500,000 rows if we go through and do all of this. And we have this recursive CTE on all these examples. I drop a test table in the form of a temp table, and clear cache. They set statistics, time, and IO on. And then this is the recursive CTE. The anchor says, yeah, go select each row from the source table. And then recursively, it's going to hum around in each one of those and add one to this task date and reflect the other dates. You'll see what it looks like here in a minute. But notice this is adding one to the task date that is formed up here. This is what's known as a recursive CTE that counts, or if you will, increments. And it's a bad code smell. And then, of course, we do our select. So let's run this bad boy. And it's going to populate that table. And that's not too bad. A lot of people look at that and they say, wow, it took a little over 2.5 seconds to make a 500,000 rows or so, or up close to that. And I'm looking at that and I'm going, okay, not only are the front enders laughing, but I've got front enders that know how to write SQL that are laughing right now, because that's horrible. And if you look at the logical reads up here, this first set of logical reads is what it read from the original table. The logical reads that it has here are the, and we'll come back to that, but that's the logical reads created by this recursive CTE. And I have to tell you, it's 8 times more. I won't demonstrate it here because we don't have time, but it's 8 times more than what a while loop would actually do. And just so that you can see what's in this table, you remember we had, I forget how many rows, but it shows the from date and the to date just to keep things going here, but it also does the task ID, the task name, and that ever increasing date. And you can see we get down to 47 rows and then task 2 starts. Okay, so what can we do instead? And I'm going to show you, this is one rendition of Itzhak Ben-Ghan's get nums function. I call it F and tally, and no, that's not actually an HR violation to say F and tally in this case. Basically, it just creates 16 rows, and then it does a cross join 8 times to give me the ability for a full gambit of all the integer value counts. In other words, 4 point. Move over here. It'll do that many rows, and I do just a little trick to give me a 0. It only counts from 0 or 1, and I can include this as well. This particular one I call tally 16 because it's based on 16 instead of my big one, which is based on 256, to add just a little speed. And there is a little trick in here if you have a batch me. I'm not using that right now, but that will help increase the speed. And yes, I know 2022 is out, and it has the generate series. So let me get back over to here. All right, let's let this run. Remember, it was taking a little over 2.5 seconds before. That's how long it takes with set based. You can see we did all the correct rows. We used a little bit more than 47, but that's a hell of a lot faster than the 2.7 seconds that it actually used. And so recursive CTEs that count or increment are really, really bad idea. And this is the output of the table. It did exactly the same thing that the recursive CTE did, except it did it at the speed of light instead of crawling through worse than a while loop. So just to summarize, count in this case means the same as increment, and that's why I call it a tally table. Tally means to count things, and that's kind of what it does. A recursive CTE, which I abbreviate as lowercase r with CTE, they're not set based. I actually have an article that I prove that in. Compared to a properly written while loop, they're 8 times slower than. They have 8 times more reads, and they're a bit slower. Compared to set based, there's no contest. The recursive CTE did the equivalent of 21 gigabytes, because if we take the page count divided by 128, that gives you this number in megabytes, which is greater than 21 gigabytes. Set based, it only did 136 or so. No contest for CPU duration. The recursive CTE, on the fastest run I could get it to do, took a little over 2.5 seconds. In set based, it was down to around 61 milliseconds. Obviously it varies with the randomness, and there's no contest for code complexity. I had a single select with a cross apply for the set based stuff, and I had a 3 select CTE for the recursive CTE. So, are there any questions that I can answer about this?
No questions I'm seeing. No one's got a hand up. I'll just make a comment as well. If you go to Stack Overflow or dba.stackexchange.com, you'll see a lot of posts by Jeff. And every single one I've ever seen has been upvoted as the best answer. So that's go check out that stuff. Whether or not he declared the term R-bar, rebar or not, that's a debate. I put the link to the Wiktionary article on there for you, Jeff.
Okay. And I guess I'll stop sharing here. And that's it for me. Thank you very much for the very kind words, James. I appreciate it.
Nice. So we'll go over to Martin next because he is front and center on my screen right now as the only other person who is sharing the video screen. So I'll pass over to you, Martin, on Sargability, which is something I know you got a bit of a passion for.
So hang on, can you all see this?
Yep.
So thank you for having me today. So yeah, so now interestingly, my company is called Sargable, and the reason for this is that Sargability in SQL Server is really, really important. And hang on, so let's talk about me because not everyone might know me. I'm a data platform MVP for 2022. More than 2 decades of experience working with SQL Server and various relational databases and data platforms. I also built SQL Watch, which is the open source and also cloud-based SQL Server monitoring solution. And I essentially help companies run SQL Server. So what is Sargable? Now, Sargable is an acronym that stands for Search Argument, which essentially means that a Sargable query is a query that can utilize the index, which means you can utilize the arguments that are for the search. Non-Sargable query means that a query, even though there is an index on a table, the query itself cannot use the index. And 9 out of 10 times, or probably 10 out of 10 times, the reason for the query not using index is because the way it was written. So obviously, understanding Sargability makes a sort of day and night difference because you can have all the indexes you want in a table, but if your query is wrong, you're not going to use those indexes. So what makes queries non-Sargable? So first of all, a couple of examples. So using functions on index columns. Okay, so anything that is calculated on the fly, like in this example. So we have an order date column that indexed, but we're using a function month, so we're extracting month from that column and we're comparing to 1. So that function makes the query non-Sargable. It's because it's calculated on the fly as the query runs. It's got to go through every single data and it's got to extract the month. It's impossible for it to use the index, and it's impossible to sort of traverse the tree of that index because it doesn't know what it's going to start with, because it doesn't know what that function will return until it runs. So how do we get around this? So obviously, don't use functions on the left-hand side of the where clause. We can actually move on to that and explain why. So do this instead, where order date and give an actual date. Now, there's a bit of a caveat with this because this could potentially still use a scan because we're scanning a large, well, potentially a number of rows. So this is going to go down to the size of a data set. The most sort of common one is using wildcards at the start of the string in the like pattern. So, and I'm sure you've seen that one. And there's plenty of examples in production systems where you have your select from, customers, etc., any table where the name like starts from the wildcard. Even though the name column is indexed, it's impossible for it to use that index because of the wildcard. So do this instead. Obviously, select start from customers for name like Smith and the wildcard. Obviously, that's not necessarily going to give us all the Smith that starts with something else. So there's some tricks to do it. Like we could use the reverse string, or we could use a bit of a approach where we actually run or have the comparison on the right hand side. But it's a bit of an advanced. It's probably more of a deep dive as opposed to a sort of lightning talk approach. So let's do a bit of a demo just to prove the point. Let me just share my management studio. Can you see all that? So what we have here, so we have some test table, simple single table with some non-cluster indexes on it. And what we're going to do, so first of all, let's see what's in that table. There's quite a few rows in that table. It's about 14,000 rows. Okay, so what we're going to do, so we're going to demonstrate the non-Sargability of the like pattern, the wildcard in the like pattern. So what we're going to do, we're going to run this query, and you can see the wildcard on the left-hand side of the string. We're going to run this, and great, we got the row, and what you'll see here, it took 9 milliseconds. Well, it took, hang on, so the total, it took 78 milliseconds. So you're going to say, oh, great, that runs in no time. Great, my query is brilliant. You look at the execution plan. Well, it's doing a table scan. It's not using an index at all, right? When we run the same, but without the wildcard on the left-hand side, that's going to run in essentially 0 milliseconds or 2 milliseconds total elapsed time. So it's much, much, much faster. And we look at the execution plan. It's actually doing index seek because it can traverse the B tree over index and it can find all the rows that starts with this. Okay, so that's a massive improvement. And although, let's just go back to the first query. if you're developing your code and you're checking performance of the code and you look at it and it runs in 60 milliseconds, you go, great, that's fast. But then in a production system, you're going to multiply it by thousands, if not millions of executions per second. And suddenly that's actually going to bring your CPU down. And it's probably going to end up with you adding more CPUs and spending more on a SQL license, because remember, SQL Server is licensed per core. So ultimately, by making your query chargeable, you're saving a lot of money potentially. So let's just go back to my presentation.
So Martin, just to let you know, there's a question from Demoderan asking how to make use of the index if you want to use some parts of the column, like a text column, using the wildcard on both ends. Is that something you think you can answer quickly, or should we leave that to after the talks where we have a bit of time?
So the answer will be, it depends. If you're trying to search for something you don't know, it's always going to be a struggle. What you could do, you could try with the reverse string option, and you start from the end of the string. But it really depends on the use case. Obviously, so you've got to think about like how indexes work in a SQL Server. It's going to start with something. Index is essentially a tree. So you start with, in this example, you start with number 6, right? So it's going to scan through the index and it'll say, right, that's number 6. So give me all the records that start with 6, and then 6, 5, 7, blah, blah, etc. So it's got a point to start with, and then it can traverse that index down. If you don't give it a point to start from, it's not going to know what to do. It's going to have to scan every single row, and it's going to say, right, does this number or does this string actually contain? Because if you put a wildcard in here, the SQL Server isn't going to say, right, give me anything that starts with anything, right? What you're looking here for, it's a string that contains that.
Just want to check, you're not sharing the screen right now.
No, right, okay, that's a fair point. Thanks. So if you're going to start your comparison with a wildcard, so essentially what this means, you're looking for anything, any string that contains that string, right? And that, by the definition, it means that you literally have to go through every single row and look for that pattern, look for that string. This could be anything, right? So essentially, just to demonstrate that, or to give you a maybe different example, let's give us that, right? So that string, let's replace the wildcard with any random string. So we could have a string that's that long, completely random. What we're looking for is this bit in the middle. There is no way on earth for any index to take us down to that string unless we use a text thread functionality in SQL Server, which is a separate daemon, which is completely different, feature. Or, yeah, it's a good question. Or we build a custom dictionary. So you split that string and say you build essentially like a dimension out of those chunks, out of those strings. But you could, if you have a customer name, second name, first name, second name, you could put them as a dictionary. But that's again, that's a bit of a deep dive into data modeling. Yeah, so realistically, when you're looking at any sort of performance tuning of queries, chargeability is the one that you should start from, because potentially you could gain a lot. So what was the question again? that's a quite a long answer.
It's fine. I think we'll loop back to it in a minute. Just doing this thing. Yeah. Do you want to finish yours off?
Yeah. But so best practices. That it's. Hang on, not sharing again.
You're
sharing. Yeah, I want to jump back to my presentation. Okay. So first of all, best practices. Understand your indexes. Know which columns are indexed in the database. Obviously, I mean, it sounds obvious, but you'd be surprised how often people get it wrong. Write your where clauses carefully. Obviously, we've just proven that if you just whack up random wildcard or anything that will make you non-chargeable, it's not going to benefit from any index. Test and analyze. Look at the execution plan. Every time every time you develop any query, every time you write any SQL code, run it and look at the execution time. Look at what the query is doing, and then regular refactoring. So depending on your approach to development, whether you have DevOps, whether you have any pull requests that you can review, etc. Make sure that you look for those things. Make sure that you review the code and make sure that your queries are chargeable. The easiest way to find any non-chargeable query right now, that's a good question. The quick one would probably be to go through all the stored procedures and the cache and see what queries are executed, because I don't think execution plan will actually tell you that it's not using an index for that particular reason. Although that's a good question, though. That's something that I have to research.
You can look for extended logical reads and maybe look for index scans and then compare whether there is an index on such a table, and maybe figure it out why is it scanning and not seeking. You could
do that, yes. Although that there's going to be
it's painfully long and slow.
Yeah, but remember, so scanning isn't always bad. As well, index scanning is not always bad, because if you see I mean, yeah, yeah. It's probably, yeah, it's one of the options probably to do it that way. Just compare those and find anything that's scanning. It's not necessarily scanning indexes because we're not looking at index scanning. We're looking at heap scanning or table scans. So that's the thing. It's completely skipping any indexes. So if we look at any queries that scan the tables and then see if those tables have indexes, and if they do, then there's an indication that we're having non-searchable queries or queries that just don't use an index. Because remember, you could have a query that's using the right wildcard, but there's no index on that column. So again, a bit long answer.
It's just looking for extensive logical reads, I guess.
Yeah.
And then finding out, whether that's because of the index, because of the not having index, or because of the searchability.
Yes. I think in SQL Watch, I can't quite remember, but in SQL Watch, we capture anything. There's an extended event session that captures queries that the sort of troublesome queries, we call them. So anything that's, anything worth attention. And I think that might also be captured, but we don't explicitly call it as in non-searchable queries because again, it could be anything. So, well, I mean, yeah, the best practice, I mean, have monitoring of any kind that will flag this up and will allow you to track those down. Any more questions?
No, I've just put a couple of comments in to say what you're describing is an ends in search, that's not sargable, whereas a starts with search is sargable. So what you can do is reverse the string, store it in a calculated column, maybe stick an index on that calculated column, and then when you do your starts with search on that calculated column, because it's been reversed, that will use an index.
Yeah.
But it's obviously it's very it does the starts with and the ends with. It doesn't solve the contains kind of searches.
Yeah.
There's no great answer. If it's a completely random search pattern, there's no great answer to that.
Yeah.
Other than things, I was just gonna say, if you're storing things like a network path, which is broken up in bits, then maybe break that into separate columns so that you can just search that column for if it's a file name or a file extension or a particular network share. If you store it in separate columns, you can just search that column that contains that data. So it's a good practice. Don't store tons and tons of things into one wide column. If it lends itself to being broken up, then break it up.
Yeah, and so reverse strings, that's something that's sort of commonly implemented, but it's more of on exception basis. You don't do it by default. You only do it where you cannot solve it, or where you have a sort of complex query that you cannot solve it with anything else. Now, but there's also another thing to be aware of. If you do, for example, from the DBO test where what do you have order date in the example equals 1, so that's going to make it non-searchable because we have a function on that end. But what you could do, although that's a bit more tricky example, if you put your, well, that's not going to work but if you put your function on that side, so what you have to do, this isn't going to work with the mom example, but say you have some custom function, right? Custom function that does something with, I don't know, order. Let's do maybe order JSON payload. I don't know, I'm just making it up, right? So that's not going to make it searchable. But if we're looking for some text. If you do that where your custom function is on that hand side, and it's doing, obviously you've got to re-engineer your function, but that as long as the function is on the right hand side, this is potentially going to use an index. Right, but there's no quick way. You have to re-engineer your code to make sure that this works the other way around. It's essentially, it's all about making sure that whatever is on that hand side, that column, is able to sort of traverse the index, if that makes sense.
It does. Just conscious of time,
Yeah.
I'd like Lee has been able to join us, and I've made Lee a presenter, so hopefully he can, if he has a screen to share, he'll be able to share that screen. Lee, are you there?
Yes, I'm here. Can you hear me?
I can indeed, and we can see you.
Okay, very good. Let me get this going here.
Thank you for getting up early to present. The same to Jeff as well. That's
yeah, yeah, no problem. Sorry about the difficulties I was having, but appreciate your patience. So, a little bit about me, since most of you don't know who I am. It's amazing to me that 16 years ago, I kind of got my start. That seems like a big number. I never would have thought about myself being in the IT field. It wasn't my intention, but I kind of fell into it. Started doing the job before I became officially a database administrator in 2014. And I'm sure that's pretty common. You get to do a job and then you get the promotion sometimes after. So I'm currently a lead cloud DBA at Upland Software, and if you want to email me, you can at that address. I'm also on X, LinkedIn, Threads, all kinds of places. So
I forgot about Threads. That's still going.
So let's go ahead and jump right in. I'm going to talk a little bit about temporal tables and what they are, what you can do with them. So a temporal table is either an existing table that you convert to that, or you could create a temporal table from the very beginning when you make the table. But basically what it is I like to think of it as it's just a normal table that you and I interact with all day, every day, but it has a companion table, often in a different schema, but it doesn't have to be, that serves as a history table. And when you have a temporal table, the system, there are two columns that get added to the normal table and the history table. You have a system start time and a system end time. And you also have to have a primary key in order to make all of this work. So this can be a replacement in some cases for triggers as a means of tracking changes to the data that's in your tables. Now, there's a small drawback in that the temporal tables don't track who made those changes. So that's a downside of temporal tables. There is an article by Aaron Bertrand out on MS SQL Tips that I have a link to there. He talks about how to merge temporal tables with triggers and do other things. I think there are at least two options on that particular MS SQL Tips article about how to get the who of making that change into the history and the event. So you can see not only what data changed, when it changed, but also who made that change. Because of course, that's the next logical question. Once you know what changed, and you then want to know, well, who did this? Who made this change? Because oftentimes you're looking at this information because something is wrong. So you want to know where did the wrong data or the wrong information come from? And so again, you'll have to mix that with some other options. There's also the new ledger feature in SQL 2022. If you're on that, that can give you the who as well as the what. But that's a totally different presentation. I just wanted to mention that. So what would you use temporal tables for? So there's a couple of usages, and in just a moment I'll have a screenshot of an example, and we can step through it. So let's just go to the screenshot because that'll be the easiest way for me to kind of explain what you would use this for. So let's say that you have a product table, and because inflation, the price is going to go up by 10%. So somebody on this call working at magical company that sells bicycles is asked to increase the price for a particular product by 10%. So you run an update statement and you do that. So what happens in the temporal table is that the original records that were updated get placed into the temporal table or the history table part of this particular feature. And that represents the first 5 rows that you see in the screenshot. So this product, this set of products, which is a yellow road frame, had a price of $549.83 before we raised the price the first time by 10%. So then the company decided 10% wasn't enough. We're going to raise it another 10% because inflation. And so you do an update again. You update the row and it's another 10% more expensive. So now the next 5 rows show $604.81. Those 2 rows represent the price during a certain time frame, which is what's showing on the left, the system start and system end time. Those show the duration or time span during which this price or this record was considered active or the truth. And so you can use this to, in this case, track price changes over time. If you're a company that does something like that, maybe you're a company that makes the bicycles, or you make a large piece of equipment that has lots of prices or lots of parts, I'm sorry, and you want to know what's the price of the parts like over time that you're buying from other vendors, so you could track trends. So you could do something like that. The other use case that I really like as a DBA is on oops changes. You can use this when you know when the change happened. You can use this history table to find what the records looked like during a certain time span, and then select these records and use that as part of fixing your data. And that short circuits the whole process of, okay, I have to go download it. I have to find a backup. I have to download it maybe from the cloud. So I have to wait for that. Then I have to restore it. Then I can start the comparison. So if you have a large database, like a 6 terabyte database, and you have to download that, then you have to restore it. You're going to wait 12 hours maybe before you can even get started fixing it. With this feature, you can start fixing it right away as soon as you know what time frame is involved. So that's really why I really like this feature quite a bit. And so that's temporal tables. And 5-ish minutes, and I'm going to go ahead and stop at this point.
Nice, thank you, Lee. I love temporal tables. They're so useful. What I would say, a slight issue or something to be careful of, is if you have a temporal table and you say update 1,000,000 rows, set column A equals column A, you will get all of those 1,000,000 records in the history table, even though nothing changed. It's not that clever, unfortunately. Yeah, if you run an update, it's going to put it in the history table. That can be a problem, especially if you're if you have developers on the box who aren't necessarily aware of that. You can quickly build up a massive table. I've just put 3 links in the comments. I don't know if everyone's heard of gists. It's kind of a feature of GitHub where you can just share code. I've got repositories called Data Quality UK, and it's all public. If you look at any code in there and recognize it as your own, please tell me and I'll put attribution. I didn't do that when I first created my repository, and then I can't remember where I got the code from. So if you see it's yours, tell me and I'll put attribution on it. But there's 3 on there where you can bulk create temporal tables. So if you're building a brand new data warehouse, you know that all these tables are going to be temporal. You can run it in bulk and it'll give you the SQL script to create them all. The third piece is you can convert an existing table to temporal quite easily. But a middle piece, I think, and I've not tried the ledger stuff yet. That's interesting. I'm going to look at that. But what the middle code I gave is kind of a way of doing an audit where you can query a temporal table and you can just get it to give you a list of, for, I don't know, order number 10 for column quantity, as an example. Show me the history of changes to that one column, and it will just give you an output of that one column before, after, when it changed. But also in that first bit of code I gave, I also put a default column on the table which captures system user. So it's not ideal if people are using different interfaces and then not just capture the SQL login that everyone's probably misusing as a separate separate thing. But it's an attempt. So I'm going to look at the ledger stuff because that seems it seems like it answers the same problem but probably does it in a better way. So I'll definitely be interested in that. So thank you for that. Like I said, I've got a passion for temporal tables. They solve when you're developing for companies and we don't care about the history of that table, and then 6 months later they did, or they do. If you turn temporal on at the beginning, it doesn't really take up any space. Be careful, because obviously if they said they didn't want tracking and you've done tracking and you end up with a problem because you did that, that's a hard one to explain. But if you just put tracking on by default and it doesn't cause any problems, you can be the savior of, especially if someone runs a delete or a truncate, you can, well, not necessarily the delete, but the truncate, you can, sorry, yes, delete would work. Drop wouldn't. So you can be the savior. So that's why I think temporal tables are great, because they've let me be the savior a few times. So
yes, for sure. The truncate is one of the limitations. So you can't make a temporal table if you have some ETL process or something where you're truncating a table and then reloading it. You can't make, the temporal table won't work in that case. But yeah, I love them. I had a situation where in one company there was Microsoft Access everywhere, and people would connect that directly to SQL Server and then make changes. And I was standing behind somebody at their desk as they were doing this one day, and we were actually talking about this issue of making changes and who's responsible for fixing it. That would be me, the DBA that you call when you mess it up. And he's typing away and talking to me, and another guy comes up behind us and says, "Oh, that change you just made, that's wrong." And I was like, "This is why I want temporal tables on this, because I could help you fix it."
Yeah.
Without,
so you can reinstate. Yeah, and I love it. I'll tell you what I might do, if you'd work with me on it as well, maybe, is a gist of, like, give me the row identifier, give me the known good date, make it a proc, and it will just restore that value back to the main table. It shouldn't be that hard to do. I've just never thought of coding it up. But I love the gist because it's a nice tool belt. When I change from database to database, I've got a tool belt that I can use.
Sure.
Right, so we're running out of time. Got 6 minutes. I've only got a 5-minute piece, so mine's gonna be quite quick anyway. And if anyone's got any questions, we can do that. So my piece was about tips and tricks of SQL Pros, which is putting me in the pros bucket, which is a little bit grandiose. From experience, I would say, have a gist. So or something else, have a notepad of functions that you use all the time. Probably if you're going to be with DBA, SP who is active, get that on there. Was that Aaron Bertrand who is active? Anyone know?
Add a mechanic.
Adam Mechanic. It's a great starter for figuring out who's causing a problem or where's the problem, because you just get users saying it's slow. Okay, well, why is it slow? It's quite a nice, easy way to see if anyone's blocking or is anything massively long running. So I was going to say, writing code, whilst SQL is much more fluid and you can write everything on one line if you wanted, mostly, don't. It's really bad. You're going to maintain your own code, more than likely. Write it in a good format. Use consistent indentation. Include comments. Everyone says that code is self-commenting. It is when you write it. When you look at it 6 months later, it might not be anymore. Use descriptive names. Don't call things A, B, C, X, Y, I, all that kind of thing. If it means order date, call it order date. Don't just call it date. Again, it's going to help you. Bit of a weird one, and I'm happy for anyone to weigh in on whether this is valid or not. Everybody always uses temp tables called hash TMP. Now, the issue for that, for me anyway, is if you've got a load of stored procedures all using the same name of your temp table. Now, technically, they won't clash because they're all in their own SPID. But I do believe the statistics roll on. So if you have a table called temp and you drop it and you recreate it on the next run of the process, even though it's exactly the same columns, etc., but it holds on to a memory of statistics, I think. So again, try not, in terms of the consideration of naming, don't just call it temp, call it what it is. Try and be specific. Break your complex queries into smaller steps. So if you have 2,000 line store procedure, that's a pretty good indication. You probably need to break that up. If you see the words go to, and that actually does work in SQL, that's a massive red flag that there's a problem. That's something you can look up called parameter sniffing. So when you first run a stored procedure, it will build a plan to how to execute, but it will do that based on the very first run. So if you've got a stored procedure that does 5 different things, it's going to have a plan that is optimal for the first thing you try. There are ways of dealing with that, but this is obviously lightning talk. I am talking quickly, I appreciate. Try writing optimized queries from the beginning. It's easy just to bash out a select star from this and then dump it to Excel and then filter it down, or take it to Power BI and filter it down, or do something like that. Try to be optimal from the beginning. So because what's used once now might be used 50 times a minute in a month. You never know. So try and build it in. So avoiding expensive operations. So cursor would be a big smell that you've probably not done it most optimally. Make sure you've got appropriate indexes on things as well. So that's what Martin was saying about checking the execution plans, and Jeff mentioned about putting your IO stats on to see what's going on. Don't forget to build in time to refactor. That's a massive pro tip. Just because you run and walk away from it, if you've got a slot in your diary for, right, let's go and query what are the most expensive things that are going on my box, preventative maintenance, go and try and make them better. Be careful, because obviously you don't want to break anything, especially in production. SQL Pro thing, try and have a production and a dev environment. Don't dev on live. Somebody will mess something up. It's guaranteed. So for that, try and have source control as well. So source control for your database, for your data definition. That you can get that through Visual Studio. There's third-party tools, but also one good thing for source control is your queries. So there's free add-ons called SSMS Boost is the free one I'm thinking of. There's also paid for ones. You've got Redgate SQL Prompt. There's Apex SQL. There's a few of them. But what they're really useful for is that person who comes and stands behind you and says, "Can you just run this one-time query?" And maybe it takes you an hour because it's a complicated query to write. You run it once, but it's only once off, so you just delete it, or you ignore it, or you don't save it. Almost guaranteed a week later someone's going to ask you to do the same thing, so you now have to spend that hour writing it again, unless you've got a tool like Boost, Prompt, Apex SQL, because you can then go in your history of executed queries and you go, what did I run for Bob last week or Sarah last week? Pick it up and just run it again. Save yourself the hour. So that's a really good one. I think that is as much as I can get through in 5 minutes. I get the feeling people watching this back might want to slow that down a bit because it's quite rapid. Jeff saying he has to, Lee's just put the link to SSMS Boost. There is a community license. There is also a paid for license. That's a great tool because you can move it from client to client to client. It's free. You do have to get permission to install it, but it's free. Another great tool, granted I'm over time, is PourSQL.com. That's really useful for, we were just talking about consistently formatting your code. If you get a piece of code, you can throw it in PourSQL, click on format, and it will put it into a pre-prescribed way of doing things. It's not got a million settings, but it's when everyone's got their own coding style. So when they throw it to you, you have to interpret their style and make it make sense. I love PourSQL for just copy paste format. Right now I understand it. Yes, so thank you to Lee and Jeff and Martin for speaking. Massively appreciate it. You wouldn't want me to just be me for an hour. Ken, you've got your hands up. Feel free to unmute.
Oh, sorry, I pressed the wrong button. I was just saying thank you very much.
No worries. Cheers, Ken.
Thank you.
Appreciate it. Thanks, everybody.
Thank you,
This will be
James. Thanks for
available
having us.
this will be available on YouTube. So I didn't catch what you said, Martin.
I was just saying thank you for having us, James. I appreciate it.
Yes,
No worries.
thank
And
you.
I'm still dodging the sun. I'm over here now.
Yeah, I can say.
Thank you, everybody. If you valued this, put a rating on whichever meetup link you came through, and we'll try and organize something similar. If you have any queries, SQL based, just drop me a message, or I'm not going to speak for the other three people who spoke, but make contact and we'll try and get an answer for you. That's what I love about this community is we try and help each other. We all level up together, so please help each other. Don't hold on to things like I found a way of doing it. Share it. That's what I think this community is amazing for. So thank you, everybody.
Sorry, I just wanted to add, absolutely, yeah. If anyone has any questions, then yeah, drop me a message and I'll be more than happy to answer. And a question around anything, but possibly even SQL Watch. If you've installed the open source SQL Watch and have any questions, drop me a message.
Yeah, I should mention it. That's not a plug. That's SQL Watch is free. It's open source. There is a paid for version, but there is a free one as well. So take a look. It might help you out a lot. Cool. And Lee has said he's also happy to answer people's questions. Jeff has unfortunately had to drop off, and so don't contact him unless you're. We don't have his permission, but I'm sure he answers questions on Stack Overflow anyway. That's another great thing. If you have questions, put it on Stack Overflow. If we can't answer them directly, yeah, just be there for each other. Be good.
Someone's asking where they can find it on YouTube. Sorry, James.
Okay, no worries. Thank you, Lee. It is, I forget the link now, but I'll put the link on LinkedIn, but I'll also put it on the LinkedIn event that is for this. I'll also put it on all of the meetup groups that were advertising this. And it's a YouTube channel, so all previous Bedrock events are also on there. Well, they're not because I'm really lazy at uploading them, but they will be eventually. Yeah. So SQL Bit Twitch Day is free. It's the Saturday. It is virtual and in person. In person, it is in Farnborough. Virtual, they have their own web interface for logging on and seeing it. I don't know if you're anywhere near Farnborough, Ken. It's a fair way for me, but.
Oh no, I'll day out really. I suppose it would be good for me, but I'm quite new to this, so it'd be nice just being just getting to meet people in person as well. It's
really good. Everyone's really friendly. If you get stuck in terms of don't know where to go, or if you go on your own and just want to meet someone and talk to somebody, look for somebody in orange top. There's something called Bits Buddies, and that's their job. Is they're there to help people.
Oh, excellent! Thank you very much. Thank you, guys.
Cheers, Ken.
Bye.
All right, thanks everyone.
Cheers, everyone.